What is the sharpest thing in the universe? I mean, my fruit knife is pretty sharp, but it still takes plenty of forces to cut through this cucumber, so it's clearly not the sharpest thing in the universe. What is?
Wait. But first, how do we even measure how sharp a thing is? I mean, we can use Celsius or Kelvin to measure temperature. Is there any way to measure sharpness? Well, it turns out there are two different approaches. First, you can measure how much force is needed to break a certain material under that sharpness. In fact, the best key C scale already uses that. And if you're a knife lover, you probably know this scale. And it suggests that the most dull knife is the butterfly knife, which makes sense because they are cool to play. I'm not trying to say that I'm cool, but like we definitely don't want to get ourselves cut. Hey, don't swipe me! Or alternatively, we could measure the thickness of a given blade. In fact, if we measure the sharpest part of a butterfly knife, it is 2.5 millimeters, but the spine of a fruit knife is 3.5 millimeters, duller than the butterfly knife. Now, a spine may be dull, but the edge, by the way, you shouldn't touch this, of a knife is 0.35 millimeters, 10 times sharper than the spine. 0.35 millimeter is a magic number. Not only is it the sharpness of the edge of your knife, it's also the sharpness of your nail tip, an iceberg, a broken glass, and
a samurai sword.
Unbelievable, right? It's crazily shocking knowing that our daily knife is just as sharp as some of the most dangerous stuff. So be careful about that. But let's get sharper.
In the best key C scale, the sharpest object was double-edged razor blade, which is 0.09 millimeters thick as a paper.
But wait, if the blade and the paper have the same thickness, how could the blade be far more dangerous than the paper? You see, it's not just related to thickness, right? To illustrate this, we need to understand how things are cut in 60 seconds.
When your knife touches the carrot, the electrons on the edge of your knife moves in contact with the electrons on the surface of your carrot. Normally, when you grab a carrot, your force is distributed all along the carrot. Thus, at each single region, the force is not strong enough to break the bond inside the carrot. However, with knife, the entirety of your hand's energy is concentrated on only a little bit of electrons. At that region, enormous repulsion force between the knife and the carrot are generated. These repulsion forces break some of the bond in the carrot, simultaneously transferring themselves deeper down the electron as you move your knife down. And if all electrons bond along a surface is broken, we say the carrot is cut.
But the electron of the carrot also repel your knife. If your knife is not stronger than the carrot, then the carrot simply cannot be cut unless you put more forces in. This explains why paper is not as dangerous as the double-edged razor blade. It is sharply soft. Let's get sharper. Past is the 0.05 millimeter lines. There are not much man-made objects sharper than this, but that will not stop our imagination. We can still go way sharper than this. You see, a natural for paper, 0.09 millimeters, has a freaking amount 10 million atoms aligned on its edge. Not impressive, right? What if I were to reduce the number of atoms from 10 million to 1 million to 1,000 to 100? In fact, what if I were to reduce the number of atoms to just 1 atom?
Introducing iSword Sharp 69, composed of tetrahedral carbon structure, the most stable structure in the entire world, with an edge thickness of only 1 carbon atom diameter. You can literally not go any smaller than this. Going smaller, guess what? Quantum mechanics says no. The particles will not stay in the same place anymore. With iSharp 69, you could literally cut anything with the tiniest amount of force.
So, looks like our iSword Sharp 69 would be the sharpest thing in the universe, right? Well, it is sharp, it just can't cut anything. Because when I use a sword, yes, it will swipe through the table, but it wouldn't actually done any cutting since the gap I've created among the electrons are so small that some of the broken bond can literally just reform. Wait, so you were saying we have the strongest material in the world, and we have the thinnest edge physics would ever allow, and it is not even that sharp. Why? Is an object's sharpness not only proportional to how thin it is? If it is, there's gotta be some point where making this thinner wouldn't actually make it sharper anymore. So what is that threshold? Well, it turns out it's roughly around 10 micrometers, which is close to the diameter of our cell. In the book, 3 Body Problems, the main character Wang Miao uses a 10 micrometer string to literally cut people in pieces. That string is called sword edge. Thus, if we are talking about the sharpest thing in the universe, then sword edge would probably be it. But at the end of the day, if your definition of sharpness is just the ability to separate things, then I would say this is your perfect candidate. Thanks for watching.